Hi everyone, welcome to week 7. We are going to continue talking about right angle triangles and in particular trigonometric ratios. Last week we defined what a trigonometric ratio is, the 6 different kinds of trigonometric ratio which you can find based on the given dimensions of the right angle triangle. Today we are going to look at a very specific triangle which is called a 30 60 90 triangle. This is what that means. This means that one of these angles is 30 degrees right here. The other angle is 60 and this has to be 90. And you can verify 60 or 30 plus 60 plus 90 is 180, which is good because that's what you need for a triangle. Now, in this triangle, we can find a relation between the sides. Find the, let's say, the relation between the lengths of these triangle by the following observation. We start with an equilateral triangle. So let me redo it here. Equilateral triangle means you've seen the definition of this. All three sides are equal. All three angles are equal. Now, if all three angles are equal, let's say I call them x, x, and x, then x plus x plus x needs to equal 180 degrees because that's the sum of the angles of a triangle, which means 3x needs to equal 180. And if you divide by 3, you get that x equals 60 degrees, or that all the angles of this triangle is 60 degrees. Now, since the sides are equal, I can call them all x's. Now, from A, I drop a 90 degrees. Now, if this is 90 and this is 60, this angle necessarily is 30 degrees. And similarly, if this is 60, this is 90 again, this has to be 30 degrees. And in an equilateral triangle, when you drop a perpendicular, it bisects the line, meaning these are equal. This is x over 2 and this is x over 2. So what it tells you is that in this kind of triangle, the side opposite the 30 degrees, right here, is half the length of the hypotenuse. Because if this is x, this is x over 2. So remember, what we have is that the side opposite to the 30 degree is half the hypotenuse. So we make a 30, 60, 90 triangle. We let one of these, the side opposite 30, be 1. That means the hypotenuse has to be 2. Why? Because half of 2 is 1. Then we can use Pythagoras to find this unknown side, and it comes out to root 3. Now we can use our knowledge from the previous week's lecture to find all these ratios. For example, if I'm looking at this 30 degrees, then I see this is root 3, 1 and 2, so that this is opposite. This is always the hypotenuse and this is adjacent. So sine would be opposite over hypotenuse, 1 over 2. Similarly, cosine, tangent, cotangent is reciprocal of tangent, secant is reciprocal of cosine, and cosecant is reciprocal of sine. But from the same triangle, I can also find 60 degrees, meaning I can find, if I look with respect to 60 degrees here to root 3, 1, the hypotenuse does not change, but now this is the opposite and this is the adjacent. And then again, I can find all 6 ratios. Similarly, we can make a 45, 45, 90 degree triangle. So let's try that. This is 90, this is 45 degrees, 45 degrees. Now you should be able to think, answer this question. What type of a triangle is this? And the answer to that is it's an isosceles triangle, right? Because two triangles are, or two sides are equal. When when two angles are equal, then the side opposite them is also equal. So these are equal. So let's say that I make this triangle and I make both of them equal to 1. Then I can find x, because x squared is 1 squared plus 1 squared, which is 2. So x is square root of 2. So this is square root of 2. Now I can again find all my ratios, because now sine 45 is opposite over hypotenuse. Cosine 45 is opposite adjacent over hypotenuse. Tangent of 45 is opposite over adjacent. Similarly, cosecant of 45 degrees is 1 over sine, so it's the reciprocal. Secant of 45 is the reciprocal of cosine, and cotangent of 45 is the reciprocal of 1, which gives me 1. So, the takeaway from this, in a sense, is we can find sine theta for various angles theta which correspond to a triangle, correspond to a right triangle. So this was very specific examples where we constructed the triangle, used some geometric properties to find the ratios. But it turns out that we can do this for any angle. We associate every trig ratio to a right triangle. But there is another way in which we can find these trig ratios, which is using a calculator. In the next video, I'm going to show you how to do that, and I'll show you how to make the settings correctly in the calculator. Yeah, so that's it for this video.